Hello students, as we all know that we were doing vector calculus, in the previous class I discussed with you about the application and the main basic concepts of the vector calculus. Now we know that in vector calculus we have to study following topics: velocity and acceleration, gradient, divergence, curl, solenoidal and irrotational vector fields, vector identities, problems based on Green's theorem and Gauss theorem, and then application for potential functions, line integral and vector. In last class, I discussed with you velocity and acceleration. Now today we will discuss about gradient, divergence, curl, solenoidal and irrotational vector fields. Let us begin, students. These were the basic concepts I discussed. What is this? We should know what is a point function, what is scalar point function, and what is vector point function. These are the base of this particular module, right? Once you know this, we have to work on these type of functions only. Now let us begin. Now we need to learn one operator. Operator is not like something complicated thing. It's simply in mathematics it plays an important role. Like differential operator you have, integral operator you have. Same way for vectors we define an operator nabla or del. It is represented by this inverted triangle. Now this nabla, it is a vector quantity and its value is I del by del x plus j del by del y plus k del by del z. But alone it does not has any significance. It has to be operated on some function, right? So it makes sense when it is applied to a scalar or vector point function. Now how we are applying will give us different things. Right, now let us see how we can do it. I can work out with it in two different ways. First, if I am talking about a scalar point function, I can operate this nabla on a scalar point function. When I am talking about vector point function, which is a vector, I can find out the product of this nabla with my vector point function. Now, if I am talking about vector products, I can have two types of product: scalar dot product, vector dot product and vector cross product. So I can see now three ways I will be using nabla: by direct applying it to scalar, by doing dot product with the vector, and by doing cross product with the vector. Now let us see how it will work and what it will give us. Now look here, suppose you have a scalar function phi and another vector function v. Let us see now how nabla is working with them. Now in the first case, see, I have operated nabla on phi. Phi is a scalar. So nabla phi. When you apply, what you are getting? This expression. And now clearly this expression is a vector. This expression gives grade of phi and it is a vector in nature. Okay. Same way now I am doing dot product of nabla with vector point function v. When you do dot product, we know it will be del by del x of v1, del by del y of v2, del by del z of v3. Because I dot I is 1, j dot j is 1 and k dot k is 1. So this will give me divergence of v. So the formula for divergence of v will be this. And clearly it is a scalar. Now come to the third one, when I am applying the nabla with v, but I am doing the cross product. Now when you are doing the cross product, this is how we solve the cross product by the determinant I, j, k, then del by del x, del by del y, del by del z, put v1, v2, v3. This will give you another vector and it is known as curve v, and this is a vector. Right? So what we have understood, nabla can give me three things. One is gradient, one is divergence and one is curl. How I got gradient? When I just operated nabla on a scalar function. When I did dot product of nabla with the vector function, I got a divergence. When I did cross product of nabla with the vector point function, I got curl. Right? Now let us understand this. Now, what is the meaning of this gradient? I use the term gradient. Mathematically, I told you how to do gradient. But what is the meaning of this gradient? See, in many practical problems like electric field, due to static charge or temperature change, or the heat flow, it is required to measure rate of change of a scalar point function. The first development of this was the concept of gradient of a scalar point function. As we saw in the previous slide, grade phi is I del phi by del x plus j del phi by del y plus k del phi by del z. What does it represent? What exactly it is? See, geometrically, gradient of a scalar field phi is vector. We saw that gradient was a vector, correct? And it is normal to the surface phi is equal to c. Its magnitude is equal to the rate of change of phi along the normal. Gradient is also known as normal vector and its magnitude is known as normal derivative. Let me explain you with this example. Suppose this is, I am showing one oven and my cookie is in a shape of this bunny and it is placed at a coordinate 352. It is a coordinate, right? X, Y and Z coordinate. In coordinate system, it is sitting at the point 352. Now, if you want to understand the concept of gradient, so my question will be, in which direction this bunny should move so that it will get the maximum of the function. Like here, what is a function? Temperature is a function because we are talking about the oven and I want it to get heated fast. So it will move in the direction of gradient. Same way, if you are standing on a hill, in which direction you should move to have the maximum slope. So wherever the function is having maximum thing, that is the gradient. And we know that when we talk about the equipotential surface, normal, the perpendicular to the surface will give you the maximum. That is the reason gradient is also known as normal vector to a surface. If it is representing the temperature, temperature will be maximum or increase along the normal. But along with the normal, it can increase in various direction also, right? And the other direction, if I try to find out gradient in the other direction, that is known as directional derivative, which we will discuss after some time, right? So what is the basic concept of gradient? Geometrically, gradient is like if you are sitting at a particular point where you should move to obtain the maximum of the function, right? So now this is the concept of gradient. Now let us see the next thing. Now, when I talk about a gradient, another term comes into mind, that is directional derivative. Now, what is directional derivative? Directional derivative is the rate of change of phi along any direction. What was gradient? Where this change was maximum. The direction in which it was maximum was gradient. Now I am saying if I want to see the rate of change of a scalar function in any particular mentioned direction, then it is called the directional derivative. And how to find out this directional derivative? See, directional derivative is given by grade phi dot n cap. What is n cap? N cap is a unit vector along the required direction. So the formula for directional derivative is grade phi dot n. What will be your working procedure? They will give you a scalar point function. Step 1, find out its gradient. Step 2, they will give you a direction in which they want. That direction is n. You find out n cap. How you will find out n cap? N cap is n upon magnitude of n. So you will get n cap. Then do the dot product of grade phi and n. That will give you the directional derivative. Now if I ask in which direction directional derivative is maximum, so what will be your answer? Directional derivative is maximum in the direction of gradient. As we told that it is always maximum in the direction of gradient. Actually, vice versa. Gradient is defined based on the maximum, right? Now, the concept of gradient can also be used to find out the angle between two surfaces. See, I told you gradient is normal to the equipotential surface given, right? So, if you have two surfaces, how to get the angle between the two surfaces? Make normal to both the surfaces and then find out cos theta, right? The same thing we will do if they are giving us two surfaces phi 1 and phi 2. I will define my cos theta as grade phi 1 dot grade phi 2 upon magnitude of grade phi 1 into magnitude of grade phi. So what type of question I will have in gradient? First direct they can give you a function, they will ask you gradient. Second, they may ask you directional derivative. Third, they may ask you find the angle between the curves. Okay, now let us move forward. Let us see one example. Now see what is given. If phi is 3 by x square minus y cube z square, find first thing grade phi at the point 1 minus 2 minus 1. Compare it with the picture. Now your cookie cake is sitting at this point. Then normal derivative. What was the normal derivative I defined? Magnitude of gradient. Unit vector normal to the surface. Unit vector normal to the surface. What is a vector normal to the surface? Gradient. And unit vector, how to find out? Gradient upon magnitude I will do. Okay, let us solve this question. Now when I am asking grade phi, means grade of, this is your del and this is your function given. Right? Now apply del by del x of this thing plus del by del y of this thing plus del by del z of this thing. I got this. Now differentiate this with respect to x. What you will get? 2x y into 3. That is 6xy. This will become 0 because x is not there. This will be 3x square minus 3y square z square, right? And this will be 0 minus 2z by cube. So this is your gradient in general. I want gradient at the point 1 minus 2 minus 1. So put the value of x, y, z as 1 minus 2 and minus 1. So this is the gradient, right? What is normal derivative? Magnitude of gradient. How to get the magnitude? Under root of minus 12 square plus minus 9 square plus minus 16 square. That is under root of 481. Now if I want unit vector normal surface to the surface, means gradient of pi upon magnitude. So this is unit vector normal to the surface. Understood the concept? Let us move to the next one. Now see this example. Show that the angle between the surfaces x square plus y square plus z square is equal to 9 and x square plus y square minus 3 minus z is equal to z is cos inverse 8 upon 3 root 21 at this point. Point is must. I need the point to work out. Now this will give me phi 1. This will give me phi 2. Okay. So I have defined my phi 1. I have defined my phi 2. What I will do? For this surface I will find out gradient. For this surface I will find out gradient. Let us do it. Phi del of phi 1 is differentiate 2xi, 2yj plus 2zk plus 0. I want at 2 minus 1, 2. Substitute x, y, z at these points. This is my grade phi 1. Same way, grade phi 2. Right? So grade phi 2 is 2xi plus 2yj minus k. At the particular point, the value is this. Now I have grade phi 1, grade phi 2. Find out the magnitude. See, the same way, magnitude I will get root 36 and root 21. Use this formula. See, substitute the values. Do the dot product. How you will do the dot product? 4 4s are 16 plus 4 minus 4. So 16 upon solving, I got this. Hence we got the result. So gradient concept is clear to all of you, and what type of question they can ask, is it clear to all of you? Let us move to the next topic now. Okay, let us see one more question based on directional derivative. Okay, now I have to find the directional derivative of this function at the point 1, 2, 3 in the direction of the line PQ, where Q is the point 5, 0, 4. Okay, and P is the point 5, 0 and 4. Okay, now how I will start? When I am talking about directional derivative, I told you I need two things. First thing, I need the gradient of the function, and second thing, I need n. So let us first find out the gradient of the function. So my function is x square minus y square plus 2z square. Find out gradient the same way, del of f. I differentiated, and at the point 1, 2, 3, I have done it. So at the point 1, 2, 3, the value of the gradient is 2i minus 4j plus 12k. Now I want to define n. They told me they want along the line PQ. So PQ is what? OQ minus OP. So OQ minus OP. That position vector of P and Q is given in the question. Okay, so this is our n, but I need n cap. What is n cap? N cap is n upon magnitude of n. So this is our n cap. Now, when I am talking about directional derivative, it is grade phi dot n cap. Grade phi dot n cap. Do the dot product. When you do the dot product, I am getting 28 upon root 21. So this is the directional derivative along the line PQ. Right? Now they are also asking me in what direction it will be maximum. So it will be maximum in the direction of gradient. Find also the magnitude of this maximum. How to get the magnitude of this maximum? Find out the magnitude of gradient. Done. So you should not get confused when you are reading out the question. Understand the concept and then do the question. Okay? Let us see further what we have. Now come to a very important concept of divergence. Now what is divergence? The divergence of differentiable vector point function v is denoted by divergence v, and it is defined as divergence v is equal to del dot v, which we have already seen earlier. Now when I do the dot product, I will get this formula. This also we have discussed earlier. Now, if we consider the motion of a fluid, divergence V gives the rate of outflow per unit volume at a point of the field. I'll explain this you with the diagram. Now, if divergence of V is 0, then it is called solenoidal. Okay, now let us try to understand what exactly is happening. First, let me explain you with a simple example. Suppose you have a box and from one side some liquid is entering or any charge particles are entering. They are entering. Okay, suppose X quantity entered inside and X quantity came out. So what was the loss of fluid inside the box? Nothing. That is the quantity, the measurement, how much is lost inside the box is called divergence. Right? So the divergence here in the first case when I am saying whatever entered that the same thing came out, divergence will be 0. Means it is a solenoid. Now I should keep in mind when I am telling you a box, if I keep on shrinking this box to a smaller size, then also my statement should be true. Right? Now, if consider a second box, what is happening? A fluid is entering and more fluid is coming out. Means divergence is positive. If fluid is entering and less fluid is coming out, means negative. So this is how we define the divergence. Okay. Now let us see how to do the questions based on divergence. Okay, before that let us understand the concept of curl also. Now if V is a vector point function, then curl V we said it is defined as curl V is equal to del cross V. Right? So del cross V is obtained in numerical. I will be directly using this formula. No need to write this expression. Curl is connected with the rotation of the charge particles and it gives a connection between the linear velocity as well as the angular velocity. So if we consider a rigid body rotating about a fixed axis with a uniform angular velocity, then the angular velocity at any point is equal to half the curl of the linear velocity at that point of the body. That is the relation between angular and linear velocity. If curl of V is equal to 0, it is known as irrotational. So now we have understood three things: gradient, divergence and curl. Now let us see how to do the question based on divergence and curl. Now look at the question. Find the divergence and curl for the vector point function this. Okay, at the point 2, -1, 1. Now when I am doing divergence, I told you del dot f. When I am doing dot product, I dot I is 1. So del by del x of xyz, del by del y of 3x square y, del by del z of x z square minus y square z. Okay. Now differentiate. If you differentiate this with respect to x, you will get yz. Here you will get 3x square. Here you will get 2xz minus y square. At the given point, if I'll find out the value, it is 14. So divergence is 14, which is a scalar. Let us see the curl. Put it in the formula which we have done. Determinant of I, j, k, del by del x, del by del z, and put the three functions f1, f2, f3. Now do the solve this determinant. How to solve this? I del by del y of this expression plus k minus k del by del z of this expression. Then do for j. When you are doing for j, I will take either negative sign outside or inside I will swap the position. Right? So, if I am taking plus means del by del z of this minus del by del x of this. Then k means del by del x of this minus del by del y of this. Differentiate, and this is our curl, that which is a vector. Okay, so this is how we can find out the divergence and curl. Now, suppose if I am giving you any scalar function and I am asking find divergence of gradient of phi. So I can do it because when I will do the gradient of scalar function, I will get a vector. And for a vector, I can always find out divergence and curl. I cannot find out divergence and curl for a scalar. I cannot find out gradient for a vector. So these things you should keep in your mind. This will help you to do the vector identities and other properties. Now look at the other example. Show that xi plus yj upon x square plus y square is both solenoidal and irrotational. Now what was solenoidal? What was irrotational? Solenoidal means when divergence is 0. Irrotational means when curl is 0. So basically you have to find out divergence and curl. Let me find out first divergence. Divergence of f is equal to del by del x of coefficient of I plus del by del y of coefficient of j plus del by del z of coefficient of k. Right? Solving it, see, if you differentiate, you have to apply the division rule. Differentiation of numerator into denominator minus differentiation of denominator into numerator upon denominator square. Okay, and see, I got 0 means it is a solenoidal. Same way, I will substitute here. I will solve the determinant and see the value of determinant is 0. Hence, it is a irrotational field. Is it clear to all of you? Let us move further. So, for today, this is sufficient. Now, in the next class, I will discuss the vector identities and the application in Green's theorem and Gauss divergence theorem. Thank you very much. Study and do so many questions so that you can get maximum practice.